Hey guys, I hope you're doing okay and enjoying the nice weather we're having after all the crazy rain. I just wanted to take a quick minute and go over some of the problems from the exit ticket you guys had yesterday. I know some of you messaged me or let me know during a meeting or whatever it was that some of the parts of it were a little bit challenging. So I'm going to take some time right now and go over a problem from each section of the exit ticket to help solidify some of your learning, and sometimes just hearing it in my words, things that you're used to hearing a little bit more, might help it make a little bit more sense. So I'm going to make this quick because I know you guys watch a lot of videos and I don't want you to stop listening to me. So let's look at number one. So number one, the directions we're asking you to solve these problems using a tape diagram. So when I look at 1A, I see 3 holes and 1/3. So I'm going to create a tape diagram that I first split into 3 whole parts, making them as equal as I can. We know it can't be perfect, but we want to try to set that goal to be very precise in our work. So this represents my 3 holes. Now I have this 1/3 to account for. So there's a couple ways I can do this. I can shade this part and label it differently with a bracket, right? And then I know 3 plus 1/3 equals 3 1/3. Or you can choose to do some shading and represent that third as a shaded portion of this. So that's where those dashed lines come in that we used way back when. And then I will shade in my 3 holes and my 1 part 1/3. But for 1A, you should have gotten 3 1/3. Okay? So when we think of that in terms of subtraction, we're going to represent that problem in a similar fashion by looking at what we already have. So I have 3 holes, and I'm going to be taking away from that 3 holes. I'm going to be taking away 1/4. So what I'm going to do once again is develop my tape diagram, partition that tape diagram into 3 parts representing 3 holes. Now, how do I take away from that 1/4? We know that the fractions are part of a whole. So I'm going to break down one of my parts into fourths. So I still have 3 holes. I haven't changed the size of the hole, but one of those is now split into parts so that I can take away that 1/4 I needed. And how I'm going to do that is simply slash that away. So now I'm looking at how much do I have left, how much do I have after I take away that 1 part. And I say I have 2 parts and 1, 2, 3/4 remaining. So that's slashing away. You really need to remember that that 1/4 isn't added on to that 3. It's being taken away from that 3. So now when we look at the next set of directions for number 2, it asked you to solve these problems utilizing a number bond and a number line. So we've talked a lot in class how a number line can easily be added above a tape diagram. So if that's something that's going to be helpful to you, make sure you do that. Just because the directions don't tell you have to doesn't mean that that's something that you're not allowed to do. So let's look at here. We have 5, and we're going to take away 2/3. So I'm going to start by reminding myself with a number bond. 5 is the equivalent of doing 4 3/3. If I were to add those together, I would get 5 as a sum. Now, the reason why I picked 3/3 is because we can see here, we have this 3 parts to make a whole. The reason I'm going to do that is I can isolate that 4 and just look at these fractional pieces to take away from, then add it back on, which is what we see here. In that similar idea, we kind of took away, so we turned 3 into 2 and 4/4, as you can see in this tape diagram, and then all I did was take away 1/4 from the 4/4. So you've kind of already been doing this. We're just showing that step now as another tool that you can use to get to that end product. Keeping in mind, once we get to the end, you can do this, you can do this, you can do whatever you need to show that you can be successful in this work. So when I think of this in terms of a tape diagram, or I'm sorry, we're not doing a tape diagram, we're doing a number line. That's what your directions said. I'm gonna go ahead and partition my number line, trying to keep those sizes as equal as possible. So I have 5 parts. Now I'm gonna partition each of these parts into thirds. 1, 2, 3, 1, 2, 3, and so on. So I know my number line is going to begin at the 5, and that's what I'm taking away from. Then I will go ahead and remove 2 thirds. So that's going to take away 1/3 and take away 2/3. That gets me in my number line to 4 1/3. Okay? Now, when we think about, well, what's the purpose of this number bond? It's a way for you to start straying away from these visual models, if you're ready, to start doing that math a little bit differently. So when we think about it, we only focused on the distance between the 4 and the 5. We split that into thirds. I'm sorry, you might not be able to see this very well. Let me go ahead and move you a little closer to me. You can see here, we only really worked with this chunk. We had the 4 and we took away from that final 3/3 at the end to get 1/3. So that's what that whole purpose is to show you why that number bond works. So when we move to questions like number 3, we can use a number bond and understand why that is helpful to us to break that down into a whole number and that fractional piece. So let's do that for number 3. This is for 3a. So we have 3 and we're taking away 1/10. Now your directions for 3 want you to just use a number bond. So notice how your steps are gradually releasing you into doing this a little bit differently, a little bit less work for you to find that answer. So I'm going to break 3 into 2 and 10/10. Okay? Similar to what I did here. I know I'm going to have these 2 holes and I only need to break apart that last hole when I'm subtracting my 1/10. When I do that, I do 10/10 minus 1/10 to get 9/10. Then I add that back on to the 2 that I didn't have to do anything with to subtract to get 2 and 9/10. Okay? So that one's going to walk you through that first part of the exit ticket.